Hi professionals, welcome back. Welcome to my channel. Yeah, thanks for your support. I can see that many people are more interested towards long videos and detailed explanation compared to short ones. So I have decided to go with long videos. So yeah, let's dive into one of the great topic today. Yeah, let's pick same area, API communication. Yeah, today let's look into Saga pattern. Okay. So it is one of the top entry questions. In many places, you might look into people are looking for some saga. But yeah, let's understand what is saga. Saga pattern is nothing but an distributed transaction. Okay, say for example, in microservices, we might be having multiple services, and if there is a before it was monolithic, we can able to go and we can do the transaction in one go, where everything belongs to the same service. So we'll be doing the transaction in series, one after other. First we'll be committing this, second we'll be committing the second transaction, like that it will be in a flow. But when we moved into the microservices world, now the transaction is spread across the services. So we need to have a good solution for distributed transactions. Okay, so here comes the Saga pattern. How Saga patterns helps here is it is using a sequence of local transactions, each with an compensating actions. That's it. Okay, this is the key. So overall topic, this is what we are going to see in an elaborated way. Lots of sequential transactions going to happen. If a single transaction get failed, a compensating action we need to go into perform. Okay, apart from that, we are going to see the two ways of saga pattern: choreography and orchestration. Okay, so let's dive into the problem. No distributed transaction in microservices. What will happen? No shared databases between services. Distributed transaction 2 PCXA. For this I will have a separate video. Two-phase commit. Okay, and don't scale well. Locks would be held across services. As you ever right, transactions always comes with the cost of lock. So locks are there, then it will be a performance killer. Network failures make coordination impossible. And yeah, for cap theorem I will have a separate session. Consistency, availability and performance. Okay, in every services, this is the benchmark we used to see. Yeah, we'll have a detailed video section on cap theorem. Okay, so for this let's focus on saga. We'll start with a quick example: sequence of local transactions and compensations. Okay, so this is a sequence. First order is getting placed, then payment is processed, inventory we are receiving the stock, and then shipping details. Okay, like this it is going to happen. Say for example, everything is in separate services. Say for example, if a third step is getting failed before that person transaction completed, that particular stock got sold to some other person, means then it will get failed. So in step 3 it is getting failed, so we'll be sending in compensation actions. That is what saga is meant for. So compensation to payment service will be doing a refund payment, and the compensation 1 order service will cancel that order. Okay, yeah, that's it. This is saga. So there will be sequence of transactions will be happening. If one fails, there will be some compensation actions will be taken care. Okay, let me go in detail how this can be done. For that we got two ways. Okay, we'll go in further section. Database scope: if there is a single, then we can go for acid, atomicity, consistency, idempotency and durability. So this also I will have a separate sessions on these areas, fine tune into my channel. Okay, single databases, and if there are multiple services involved, then we need to go for a saga pattern. Consistency model: acid, it is strong and it is eventual based. Say for example, it depends on one event and then another. Yeah, we'll go into detail when we are going to the types. Okay, locking: yes, holds a lock. No locks are there in saga patterns. Isolation: it is irresolvable. There is no isolation. Scalability: it is limited, it is high. Failure handling: automatic rollback, compensation transaction. And complexity, it is slow because it is straightforward, only one thing is involved, everything in one place, so it will be easy. But the complexity, it is very high. Best of all, single service operation and multiple service get involved, then you need to go for Saga pattern. Okay, let's dive into the types. The first type is choreography. We can do Saga, we can perform Saga in two ways. One is choreography and second one is orchestration. Okay, choreography is nothing but event driven sagas. Say for example, if a particular event, a particular action has been done, a event will be published and then order will continue its own work. Okay, who are interested, they need to pick that particular, they need to listen to that particular event and they need to perform the next action. Okay, this is a good example. Once order is done, order created event will be published. Payment service will be checking for that order creation event, and once order creation is received, then it will do the payment and then it will do the another event, payment success. Once payment success is done, then it will go and do that stock reserved, and once stock is reserved, then the shipping details will be done. You can see here every action, a event is getting published from every service. Okay, so it might be in order, but there is no centralized system or something like that. Everything works individually. Okay, no one cares about no one. Okay, that is the concept of choreography. Order, they worry only about their order creation, they don't worry what happens further. Okay, so in the same way, all others will be working, all will be individually developed and individually maintained. And in the same way, Saga, the basic core principle is we need to do that compensation, right? How the compensation works here is, in case if there is any failure in stock reserved or something, a event failure payment will be sent, and that failure payment will be received into payment service and then it will perform that compensation action. Once that failure payment compensation is done, it will publish a event called cancel order, and then order will be cancelled. Like that, it will be happened, and everything will be interrelated, and no one cares about other persons. Yeah, let's look into some of the advantages of choreography. There is no central point of failure. There is no central system or something. So even if one service is failed, others will be publishing the events and it will be processing. Simple to implement. Don't worry about others. Let's implement. We'll focus on our business and we'll do. Good for scalability. Loose coupling between the services. Easy to add new participants. Okay. If you record, you can add a particular service in between and then you can do that chaining. Okay. These are the some of the advantages of choreography. Some of the disadvantages are hard to debug. Okay, once we lost, we are not sure where it has been went and how to see the failure. Risk of cyclic dependencies. If event has been cycled, then that's it. We'll be going in a loop around and around. Complex error handling. Error handling also will be a headache. No central audit trails. Hard to manage complex workflows. If the flows are complex, as I said, it is simple, right? But in reality, there might be some complex flows. It is hard to do. Yeah, that's it about choreography. Let's jump into orchestration. Orchestration is nothing but a centralized system will be there, a coordinator, central coordinator will be there. Everything will be communicating with that particular central coordinator. Let's take the same example. First order will be created, it will be sent to central coordinator. They'll be informing that, hi, I have done that order has been created. So they will check and they will be aware what needs to be done next. So they'll be doing that next thing. It will be sending to payment for doing that payment. Once payment is done, it will come back to the coordinator and then again it will go to the reserving the inventory. In the same way, it will be going and coming back. If there is any failures, this central coordinator is aware about the compensation action. The same example, if inventory it goes out of stock, what happens is it will go for central coordinator will be sending that event to the payment system. Here what it will be happening is payment will be reversed and then again it will come to central coordinator and again central coordinator will be doing that compensation for order as well. They will cancel that order. Okay, so this is another one of the key item for Saga and most widely used item. Okay, in most of the microservices in our industry, they are following the orchestration pattern. It gives us some strength. but I would say that it depends on case to case only. In our case, I have worked on twice with Saga. I have worked on both. I got a good hands-on in both. Both this will be complex. I can see that we used to do that choreography in a complex way, where multiple events will be flowing here and there, and there might be some sequential issues might be happening. Lots of issues raised in choreograph. But from my personal experience, would suggest that orchestration is a good one. For simple flows, go for orchestration. Okay. And coming to advantages, central visibility and control. You have control over everything, right? Because you got a centralized system. Easier to debug, clear to audit, simple error handling, supports complex branching. If you do all the monitoring, all the observability over this particular central coordinator, you can see what is happening in the system. Okay, this is the biggest advantage for orchestration. Some of the disadvantages: orchestration is single point of failure. If the central coordinates is down, then the entire thing is going to be collapsed. Can become performance bottleneck because everything goes into and it is coming back in and out. It is happening to the central coordinator, so there might be some performance bottleneck. More infrastructure complexity. Orchestration business logic can go complex. More and more compensation actions you need to perform, and it will be more complex. And centralized equal to potential coupling. Everything will be tightly coupled to the central coordinator. Okay, this is some of the disadvantages of orchestration. Now quickly compare decentralized and this is centralized. It is event based and this is commands, synchronous and asynchronous commands. It will be between API communications will be happening. Visibility, it is slow, it is high. Debugging, it is difficult, it is easier. Scalability, it is excellent. Limited by orchestrator. Single point of failure, no, but in orchestrator, yes. Complex workflow, hard to manage, well suited. And the cyclic dependencies high, but here it is low because we got a centralized person supervising everything, so the cyclic will be very less. Best for simple and linear workflows, and it is bit suited for complex and branching workflows. Some of the quick examples I have given. Okay, so as we discussed, these are some of the good examples. You can pause the video and you can quickly go through these items. When to use what? Workflow has 2 to 4 steps, simple and linear, go for choreography. If it is going to hop between 3 to 4 services or 2 to 3 services, then it is linear, 2 to 4 steps. The good choice is choreography. Teams want full autonomy, you need to work individually, then you can go for choreography. You have a good event-driven infrastructure, a Kafka, RabbitMQ, you already got in place, then go for choreography. No need for central audit or trial, then go for choreography. Service can work independently, low coordination, overhead needed. And when to choose the orchestration? Workflow has complex branching, conditional logics and all, then go for orchestration because this will be helpful while you are doing the compensation actions. Central visibility and audit trail required, then you can go for orchestration. Some critical systems, when you are going to perform that services, what services is communicating with to what, and you need to visually see the complex transactions, then you need to go for orchestration. Multiple sagas share common steps, need ability to resume sagas after failures, complaints request transaction logs, business rules change frequently. Travel booking with flights, hotel costs, insurance, those and all you can do for orchestration. And some linear example is order payment and inventory. Okay, with this you will be clear, right? When to use choreography and when to use the orchestration. Some real world examples: travel booking, banking, insurance. As I said, right, debit account A, credit account B, that's it. Credit account A, debit account B, that's it. So like this, the compensations and examples we can say. You can quickly pause the video and you can see that real world examples. Common pitfalls: non-idempotent, duplicate payments on retry. Okay, to overcome that, we need to go idempotency keys plus unique database constraints. Idempotency is nothing but say for example, if user is clicking the payment, okay, it is not happening again, by accidentally is clicking again the same payment link. So during that occasions, two requests might be coming and two payments transactions might be happening. So to overcome that, we need to have an idempotency key and we need to have an idempotent system. Okay, I will have a separate topic for this. I will discuss in detail about how to overcome this identity problem. Okay, missing compensations, partial rollback, and others. Long running sagas will be there, and low visibility, cannot debug failures, compensation failures, stuck in consistent state. Say for example, you might be written some compensations, but in the other service they might be not, might be changed the logic or done some other thing. Okay, so do that you can use this letter Q plus man to invention alert. Okay, dead letter Q is nothing but a separate queue. Say for example, if you are using a Kafka means DLQ, they will say dead letter Q. In that, you need to create a separate topic, and what are failures happening in the microservices, you need to publish that message to DLQ. Okay, and then whenever your support or whoever is working on supporting the application, they need to always check this queue, and they need to do the manual intervention, and they need to come up with the solutions. Okay, this is about DLQ. No timeout handling, sagas never completes. Implement Saga without timeouts and schedule compensations. Shared databases between services. Services are not independent. Enforce database per service. Okay, this and all we'll cover under microservices. Okay, idempotency, I will cover it in a separate topic, separate video. Okay, so quick sample is this one. Balance equal to 1000, same result every time. So whenever you are hitting that particular person's account balance, it needs to give 1000. Okay, status cancelled where id equal to 123, delete from cart where user id equal to 456. So always have like this. Non-idempotent is, say for example, increasing, set the balance. Here you can see the difference, right? Non-idempotent and idempotent, you are setting that balance itself 2000, but you can see here, right, you are adding 100 to the balance. Both gives us different meaning. Okay, so yeah, I will go in detail. This is an important topic for both interview perspective, also in real life. So I will cover it in a separate topic. This is a quick example. Instead of updating the balance, if you add to the balance, then it will create lots of issues. Okay, that's it for now. And best practices: design compensation first, then forward transaction. That is one of the good way. Make all operations idempotent. Store Saga state persistently. Database, not just memory. Don't use cache or something. Use always databases. Implement timeouts for every step. Monitor sagas actively. Have manual intervention plan for unrecoverable states. Implement DLQ. Log every step with correlation ID. Correlation ID is for that particular transaction which is spanning across multiple services. You need to have the same ID. Keep saga short, and test compensation pairs as thoroughly as successful paths. Okay, yeah, these are the some best practices, popular sagas. You can pause on and you can check. And yeah, this is the final step. Saga replaces ACID with eventual consistency using compensation transaction. Each step has a corresponding compensation that undergoes its effects, its later steps fail. Okay, this is a quick summary. And mental model: Saga, multiple chefs coordinating via messages. Acid, single chef in one kitchen. Okay, Saga, multiple chefs coordinating via messages. That's it. This is a great mental model. Then choreography: dances without a leader. Orchestration: conductor leading the orchestrator. Compensation: undo button for each action. Okay, yeah, that's it. This is a quick memory items you can remember. Saga replaces distributed transaction with compensations. Trade ACID for base. Lock for events. Strong consistency for eventual consistency. Okay, key takeaways: Saga, it's not an ACID. Two patterns: choreography, orchestration. Every step needs a compensation. Idempotency is mandatory. Store Saga state. These are the 5 takeaways you need to keep in mind. Whenever you are discussing about sagas, you need to be clear on these 5 items. Okay, remember tips: choreograph, simple, scalable, hard to debug. Orchestration, complex, visible, and centralized systems. Okay, yeah, that's it for today. Hope this is a very wide topic, but I try to cover as much as possible, and I try to keep it simple. Okay, keep supporting and keep watching. I will add more and more videos for your interview preparation. Okay, yeah, cheers.